Two problems, one solved. I got a call for both the idle wheel and the drive wheel because they're both giving problems. I'm going to get into it. I'm Jeremy with I Machine Services. I have over 20 years servicing industrial bandsaws. And let me talk to you, let you know what I've found. If you guys would like to comment, I would love it if you guys would let us know ideas for videos. So let's get into this machine. So the first issue they called me about was an idle wheel bearings. They could see the balls inside, which is not a positive thing. So they gave me a call for that. They kept running the machine, not ideal. Then they let me know about the drive wheel was actually coming off the shaft. They were concerned about gearbox problems because that's where the gearbox ride is, on the drive side. Okay, so what I found when I got there was the drive wheel was definitely coming far off. And what happened was it had taken out the blade brush assembly. It had destroyed that on the process. So what I did is I completely took it off. I cleaned it all up and I put it back on. I tightened the QD hub well. And then what we found is that the blade speed was quite high and it might be a vibrations issue, which is another issue. Okay. But I did get that side fixed and I gave them things to look for that future, so that we do not have these issues in the ongoing, and we don't want this to keep going. The second issue, which was the original call, was the idle wheel bearings. So what we did was we replaced the idle wheel bearings. I have tips and tricks, and I will go over this in one moment. I'm going to go to the shop. I'm going to get in front of the whiteboard, and I'm going to go over both the QD hub and the idle wheel. I want to show you guys some special things on that so that you guys can understand what to look for, good ways to replace bearings, as well as things to know about the QD hub. So I will be back in a little bit, and we will go over this. Okay, guys, we're back here at the shop. I gave us some illustrations right here to look over. I really want to learn about the idle wheel and the drive wheel, the QD hub, which is going to be on the drive wheel, and your idle wheel, which is going to be on the bearings that go on the idle wheel. So another thing to keep in mind, this is standard, but there's always exceptions. Please keep that in mind. Okay, the first thing I want to go over is the drive wheel. Okay, I've got a couple markers here so that we can help illustrate with some color coding. Okay, we have the drive wheel. Okay, and I'm coloring it in blue right here. And it goes all the way around. You know, this piece here is the drive wheel. Okay, now I'm going to color the gearbox shaft, which is this piece here. It's that piece in the middle. Okay, I hope you can see that well. And then with green, I'm going to color in the QD hub. Okay, this is this piece right here. Now, I have the same thing illustrated on its side right here. And I'm going to color code him for you. Okay, so QD hub is green. Okay, it's this piece right here. Okay, we got the gearbox output shaft is red, which is this guy right here. Okay, and then for blue, I've got the drive wheel. Okay. Beautiful coloring. Thank you so much. I appreciate it. Okay, so this is to help distinguish what is what. Let me put the markers down since we're done with the markers for now. Okay, so what I want to illustrate is that on the drive wheel, you see, and I've got this exaggerated so we can help illustrate it. On the drive wheel, you see how it's conical here, and then we have the conical on the QD hub. Now these are circular, there's a cut, okay? But as this squeezes together, it's gonna constrict on the shaft. And then once you get him placed where you want him placed, what's gonna happen is he's going to constrict on the shaft without you having to do anything to the shaft other than that constriction, okay? So as you put these bolts in and he gets tighter, as you bring him down lower and lower, he's going to wedge in, and then he's going to lock himself on the shaft. What I think that potentially happened on the job today is that if this is worn or this is worn, he's sitting too low down, and then he's not able to constrict on the shaft well, and then maybe you get some movement, or he's not tight enough. But that is what we found on the drive wheel. Okay, so that's this guy. I hope this makes sense. I do ask you if you have any questions on this, please leave a comment below. Okay, second piece, we have the idle wheel. Okay, the idle wheel, you're going to have your idle wheel shaft in the middle. You're going to have your bearings, and then you're going to have the wheel. Okay, so basically three components. Usually there's two bearings, okay, which I have them illustrated here. So on this guy here, you've got your wheel. And then we're going to have our bearings, which are these guys right here. Okay, now I've got a bearing here. This style bearing, not all idle wheels use this. Okay, this guy has a snap ring. Hope you can see that. You see that snap ring on there? Okay, so basically we're gonna press or beat this in with a hammer until it sits so that the snap ring prevents it from going any lower. And that's where he's gonna sit. He's gonna sit right there. And same thing on the bottom. So you're gonna have two of these, one on both sides. Now, one of the problems with that is we're gonna have all this air in here, okay? Which is usually not a huge deal. But these are bearings that are rubber sealed, so these do not need to be lubricated in any way or greased, okay? But this air section here, because we're working with a bandsaw, you've got coolant. Sometimes you got to worry about coolant, okay, getting in here. Okay, so sometimes we'll fill this with grease just as displacement, not necessarily as a lubricant, but as displacement. So the shaft and the interior of the idle wheel, okay, does not get full of coolant, which then leads to rust and more problems. Okay, now, one of the problems that we have with these bearings on the wheel is that he sits inside of there, okay, and what happens is he'll start to move and the wheel will not move. And so he'll start to dig out part of the idle wheel ID, okay, or the interior diameter, okay. And as that happens, find the black, as that happens, okay, what's going to happen is you're going to have a little bit of a wallered out area right here, okay? So there's several options you can do, okay? You can take this to a machine shop, okay? And you can get it sleeved. That is always an option. You can just sleeve this whole thing. And on this style, it is one size from top to bottom, okay? Not all idle wheels are like this, and they're all going to be dependent on style, okay? The second thing is you can use something called bearing retaining compound, okay? Which is something I do use, okay? The stuff I use is a Loctite, okay? I also use another brand that we will be moving to. This is our old stuff, but you got a primer, and then you got your main bearing retainer compound, okay? And this helps keep the bearings in place so they'll stay there. They also have a cure time, so it does need usually 12 to 24 hours, so it's just something to keep in mind. Okay, but another thing I'll do is instead of putting that bearing back in there, I'll put what's called a double bearing in there. So this is a single tall bearing. You can get a double tall bearing with that snap ring on there, and then I will put that in here, okay? I'll put that in here instead of the normal single bearing, okay? And then he will sit in this fresh area here, okay? He'll sit in basically virgin interior diameter that's never been touched by a bearing, so he's not wallered out. I'll then add my bearing retain compound, and then that will help us so that we can basically prolong the life of this wheel without either having to replace the wheel or potentially have to get it machined, which can be cost prohibitive depending on the size of the wheel, stuff like that. That's something that I can do in the field, and I don't necessarily have to take it somewhere else who's going to slow me down, different things like that. Okay, but I hope this helps you with the drive wheel and the idle wheel, as well as the cutie hub with the bearing placement. Remember, you can use a double bearing as well as using a bearing retaining compound. Okay, and I use a Loctite, but we're moving to a different brand that does not require the primer. And again, remember on that 12 to 24 hours to cure, best case, which again, the real world, that's not always the thing. Last thing, put grease in this cavity, okay? So it displaces coolant, so coolant has nowhere to go in there, and that's a big deal also. If this was helpful, please hit like and subscribe. More bandsaw content is coming. Drop a comment. What type of saw are you running? What kind of shop you're in, as well as what kind of material you're cutting. If you're in the Gulf Coast region and need your bandsaw service, please give us a call or shoot us an email. I Machine Services in Houston, Texas. We travel where you need us. Links are below. You guys have a wonderful day. Thank you so much.